many people will need this recording today. And I want to start, I'm going to share my screen with you. We're going to go over the homework, not read the New York Times. So I think this was for the problem. Oh no, wait a minute, that's the new thing. This was the solution to the problem that we would have done in class yesterday, but we ran out of time. So I think I gave you those answers at the end of class yesterday. So are there questions on this one? This is the one that had both the table and the graph.
I'm a little confused. Like, I understand.
Wait, you're breaking up, Jacqueline. Start again, please.
Sorry, yeah, I'll put my computer on a pillow underneath this. I'm a little, like, I understand, like, how the mean value theorem, it's like, if it's, like, continuous and differentiable, like, or around the interval, like, at any point, it will be, like...
Well, that means that there must be some point that has the same slope as what the average is.
Okay, perfect. Okay,
so if you have your function, actually, I don't like that function. It works a little bit better like this. If you have your function, again, I don't like that function either. Hang on, let me try one more time. If you have a function like that, say, okay, so if we took that average slope, which might look something like this, okay, and that's basically going to be like delta y over delta x, okay, then that means that there has to be some point that has the same slope as that. Okay, but remember that for the mean value theorem, that a really important part of that is that your function is differentiable and continuous. And remember as well that differentiability implies continuity. If it's differentiable everywhere, it's continuous, but it doesn't work backwards. So that if it's continuous, that doesn't mean it's differentiable, because I could have something like that, where my pen has never left the paper, so it's continuous, but it's not differentiable up there at that cusp. Okay? Any other questions on this one? All right, then the actual homework was 2013 number 4, which had the swoopy curve. So if you want to check your answers to that, and then we can go over anything there. Oops, I have no idea what just happened there. Okay, so are there any questions on this one?
Can we do B and D?
Sure. So, just so that we're making sure that we're all on the same thing here. Oh, that's the wrong one. So we are here. And we're working on this one here, okay, with the swoopiness. So part B says determine the absolute minimum value of f on the closed interval from 0 to 8. Okay, so first of all, remember that what is plotted in that graph here is f prime. Okay, so when we are looking for absolute minimum values, we have to start by identifying what our critical points are going to be, or our stationary points. So that means we're looking for places where f prime of x is equal to what?
0.
0 or
not defined.
right, doesn't exist. And because this is a closed interval, okay, because it's x, sorry, 0 is less than or equal to x is less than or equal to 8, now we also have to think about the endpoints. So kind of our options, our candidates here are x equals 0, x equals 8, because those are the endpoints. And then I'm going to go back and look at my graph here, and I'm looking for places where the graph crosses the x-axis, because this is a graph of f prime, and I'm looking for the places where f prime is equal to 0. Okay, so just like I had them, because we kind of did this a little bit in part A, my candidates might be 1, it might be, what is that, 4, and 6. Okay. So we kind of already decided that x equals 1 is not a max or a min, right? You should have figured that out in part A because the sign of f prime doesn't change. Okay, and then we said that you should have also figured out that x4 is a max, and we already identified that x equals 6 is a min. Okay, so now you got to look at your endpoints. All right, so if I have a point, let's see, so I want to look at 0 and I want to look at 1. So if I look at 0, just going to go back here for a minute. If I look at 0, over here, my f double prime is less than 0, right? F double prime would be the slope of a graph of f prime, right? Okay, and what does f double prime tell me about concavity? If f double prime is less than 0, what kind of concavity do I have?
Concave down.
Concave down. So it's going to look like this. Okay, over here at x equals 8, what's the sign of f double prime going to be? Helen?
Positive.
Yeah, okay, those slopes are positive there. And if f double prime is greater than 0, what does that tell me about the concavity?
Concave up.
Concave up, so it's going to look like this. Okay, so that means that the extreme point that I might have at x equals 0, is that going to be a max or a min?
Min.
At
Oh,
x
at
equals
x
0?
equals 0? Max.
Yeah, max. Okay, so x equals 0 is going to be a max, and x equals 8 is going to be a min, although I'm actually not sure if I agree with that at the moment. Because I seem to think that x equals 0 is a min. No, I don't. Never mind.
Why would f double prime be less than 0 for 0? For the first one.
Well, because do you understand that f double prime is the slope of an f prime graph?
Yeah.
Okay, well, what do these slopes look like
Oh,
here?
decreasing.
Yeah,
Okay.
well, well, they're not just decreasing, they're negative.
Yeah.
Okay, that's different than decreasing. Okay, so I've got my two candidates here, x equals 6 and x equals 8, and now I have to figure out which one is going to be the absolute minimum. So I actually need to figure out what f of 8 and f of 6 are. Okay. Why do I feel like I have this backwards?
Okay, guys.
Yes.
I feel like x equals to 0 is a
I
minimum
do too.
because
I
it concaves I don't know what's the word, concave down. So like it should be on the left side, so it goes up and then goes down. So that's why I think it might be a minimum.
I think you're absolutely right, Helen. I think we need to look at that again because I don't have that in my notes. But I think Helen is right. And actually maxes and mins should alternate. So if x equals 6 is a min, then x equals 8 has to be a max. So there are a whole bunch of reasons. So we want to look at this one and this one.
Oh, can we go over why x equals 0 is the min and x equals 8 is the max?
Yes. I have to think about it for a minute though.
Oh, okay.
Because this is what I have in my notes, but I don't have how I knew that x equals 0 is going to be a min. So let's go back and look for a minute at the original problem. Okay, it would seem that my f double prime thing is not working. So let's just erase that. Okay, so what this is telling me is that, what's this telling me here? Helen, why don't you try explaining again?
I think that like your f double prime actually works because you know like x equals 0 is concave down, right?
Mm-hmm.
So it goes up first and then goes down. So which means 0 is like the left end point of the parabola.
I think you have the middle too. Like, shouldn't like x equals 6, the slope goes from negative to positive. So wouldn't it be a minimum?
Yeah, this is a
Oh,
min, definitely. Yeah. I'm totally with you there that that's a min.
Okay.
Totally.
Never mind.
No, that's okay. So how do I, and this has to be, this could be a max. Because what would happen is I'm coming from this min and then whatever I get to over here on the end is going to have to be the max because there's nothing beyond it. So I feel good about that. It's just a matter of figuring this out. And I guess I might think, so that's a min, that's a max, and this is like nothing. So I'm kind of wondering if it kind of sort of looks like that, where this is x equals 6. This is x equals 4. This kind of saddle point here where like you would think that the derivative, the slope would be horizontal, that's x equals 1. And then coming from over here would be x equals 0, and this would be x equals 8. And I think what it has to do with is this point here, in that something happens there. And okay, I got it. All of this has f prime greater than 0, right? And so that means, and I'm going to erase this a little bit here, that means that the slope has to be increasing, right? The curve has to be going up, or my function has to be increasing, not the slope, okay? But f prime greater than 0 means that my function has to be increasing. So I start over here at x equals 0, and I increase. I got something funky going on at x equals 1, and I have to increase to all the way to x equals 4. So if my function has to increase all the way from x equals 0 to x equals 4, because that's what this tells me, then x equals 0 has to be some kind of a minimum. Okay, it could be that like the curve goes like this, so it is in fact concave down. But the bottom line is that the f prime of x being greater than 0 tells me my function has to keep increasing. So down here at x equals 0, that has to be some kind of minimum. Okay, does everybody follow that logic now? Lauren, you okay?
Yeah.
Okay, well, no, it's good, and we really
do that on my own.
well, yeah, but you gotta.
Yeah.
Okay, but that's where all of this is coming from, is that f prime of x is greater than 0. So my function is on this increasing trajectory. Okay, and that's part of this, is being able to put all those pieces together. Okay, so we know that the two things we're looking at, the 2 points we're looking at, are x equals 0 and x equals 6. And now we need to figure out what the actual values of the function are at those 2 places. Okay, so I happen to know, because they told me, that f of 8 is equal to what, 4? Okay, and the only information that I really have here is the area under the curve. So the way that we end up solving this is to say, well, if I look at the area under the curve, say from 0 to 8 of f prime of x dx, okay, and remember that that's what an integral means, is finding the area under the curve, then this is going to be, by the fundamental theorem of calculus, f of 8 minus f of 0. Okay, and I know that f of 8 is 4, and f of 0 is what I'm looking for. If I can compare f of 0 and f of 6, then I can figure out which one is the lower minimum, because I am looking for the absolute minimum. Okay, and then basically we add up all of the area under the curve from 0 to 8, which is 2 plus 6 minus 3 plus 7, right? If I just go through and take all of my areas, so this is 2, this is 6, this is going to be negative 3, and that's going to be positive 7. Wrong thing. Oh, that's okay. This is what I want. And that, I believe, is 12. So that tells me that f of 0 is equal to negative 8. Okay, everybody there? Okay, then you figure out what f of 6 is. Is there anybody who has no idea how to find f of 6? A hint for finding f of 6 is remembering that the integral from 6 to 8 of f prime of x dx is going to be f of 8 minus f of 6.
Okay, if we also did it like 0 to 6?
No. Well, knowing that f of 0 is negative 8.
Yeah.
You could. That violates what I would have to say is not a law of calculus, but for me, it's a personal test taking AP thing. What if you mess this up?
Well,
What
if
if you
the other one up? Isn't there like an equal?
no, because f of 8 being equal to 4 is something that I'm given.
Okay.
So my advice to test takers, and it has been for 20 years, is if you can figure out what you need to figure out using only the information you're given, then you should. Because you could have messed that up. You could have decided it was positive 8 because you did it real fast. And you've had a 12 and a 4, so of course it would be 8. And then that's an error that's going to carry through, and they will give you partial credit for that, but then it's partial credit, whereas if you had gone back and used the information you were given and where your possible error isn't part of it. I just think that's a better way to do it. If you're super confident in what you're doing, then go for it and use your answers. But my advice would always be to try to only use what you're given if possible. And sometimes that's not possible. Sometimes it'll say using your answer from part B. And what are you going to do?
I'm getting 2 different answers when I do it. I'm getting negative and positive 3.
The answer should be negative 3.
Okay.
Is that what you get when you do it my way?
Yeah. Yeah.
If you go 0 to 6, are you remembering that the area under the x-axis is negative?
Okay. Yep, that's it. That's it. I was messing that up. Thank you.
How did you get f of 6? It's just the area under the curve of 6, right?
Well, no. As I wrote here, it's if I take this differential here, not differential, this integral equation, okay, it's going to be equal to f of 8 minus f of 6. So if I look at my curve, okay, from, and I got a lot of draw, go away, cancel, draw, erase. Okay, we got a lot of junk going on here, okay? But if I just want to take the area from 6 to 8 here, I know what that is, right? It's 7, positive 7. So if I go back here, this side is 7. I know that f of 8 is still 4 minus f of 6. And you can do all the algebra, but when you look at it, f of 6 needs to be negative 3. And what this problem asks you for is what that absolute minimum value is. Not where it is, but what it is. So the answer is actually negative 8. Okay, are we good on this? It's kind of wacky. Well, it's not really wacky, but you got to put a lot of things together to make it work. Okay, we good? Okay, so somebody wanted to see part D as well. So D says the function g is defined by g of x is equal to f of x cubed. And we are told that f of 3 is equal to -5/2, and you want to find the slope of the line tangent to the graph of g at x equals 3. So what's the calculus word for the slope of the tangent line? What? Somebody say it more clearly, please.
Derivative?
Yeah, it's the derivative. Okay? So basically, I want to find g prime of 3. So the first thing that I need to find is g prime. But you might want to look at it as, u is equal to f of x. Du dx is equal to f prime of x. And then I can say that g of x is u cubed. Okay. So that when I come back over here and take the derivative of this, first of all, I have to use power rule, right? Because I've got u cubed. So it's going to be 3 u squared times du dx. Does everybody understand where that comes from? Anybody not understand where that comes from? It's come up a bunch of times and it will continue to come up. So if I substitute back in, that's 3 times f of x, that whole thing squared, times f prime of x. And then I want to find the whole thing for 3, for x equals 3. So that's 3 times f of 3, that whole thing squared, times f prime of 3. So I'm told what f of 3 is. So I'm just going to put -5/2 in there and square it. And then where do you think I'm going to get f prime of 3? Where? Yeah, from the graph. Okay, so if I go back here, remember this is a graph of f prime. Here's x equals 3. So what's f prime of 3 equal to? 4. Okay, so I read that off the graph and it gives me 4. And then I just have to do all the math. Okay, so remember that this negative sign is inside my parentheses, so when I square it, it goes away. So that's going to give me 3 times 25 over 4 times 4, or 75. Okay. Are we good? All right. So that is the end of type 3 problems. We're going to skip type 4 problems for now. Those for BC folks, you will need to review those when you get there. But right now, I want to talk about type 5 problems. Okay, so type 5 problems are table and Riemann sum questions. So some of the things that you're asked to do is to maybe find the average rate of change over an interval. So you'll probably have a table of values, and maybe you're supposed to figure out, you know, what the average rate of change is between 3 and 5. And that's just taking delta F over delta X. You might be asked to find the slope, or again, the rate of change between two adjacent table entries. And sometimes they'll talk about that as approximating the derivative at a point. And finally, you might have to use LRAM. Oops, let's just write that again. RRAM, MRAM, or the trapezoidal rule.
Where are the, again, I'm sorry, I forgot. Where are the LRAMs and RRAMs on the calculator again?
It doesn't matter because you're not allowed, you won't be allowed to use them.
Oh, okay.
It won't, because the whole point is, can you do that? And we'll do an example. But remember that it depends on, let's see, let me see what's here. If we bop down here for a minute and go to the type 5 problems. Here, okay, if you're going to use LRAM, okay, this is going to be my interval. It has a width of 1. If I'm using LRAM, then I take the value on this side. If I'm using RRAM, I take the value on this side. Okay, if I was going to use MRAM, I would have to use a bigger interval. Okay, but it's a matter of which kind of height of your rectangle you take, whether you're taking it from the left side of the interval or the right side of the interval.
Dr. Getz?
Yes.
What I think it's called Simpson's rule. Is that right? Would that be included on the AP exam or no?
I suppose it might be. I don't know. We'd have to look that up if that particularly would be there. My gut would say not this year.
Okay.
Because there's just too many other things they're trying to cram into those 2 problems that memorizing that's probably beyond it, but it's probably in here. I don't have it in my notes,
Okay.
but I think it probably could be.
Okay. Thank you.
Sure. All right, did everybody copy down what they need to copy down from here? Anybody need more time? Okay, so a couple other things that often go through here. We talked about average value. We talked about average rate of change. We've talked a bit about the mean value theorem, okay, and that f of x has to be continuous on the closed interval and differentiable on the open interval. Okay, and that is the first criteria, and that if that is not met, then you can't apply the mean value theorem. And that means that there has to be some point C such that f prime of C is equal to f of B minus f of A all over B minus A. And we just had that in the problem that we were working with earlier today. One kind of corollary to that you read about, but I never talk about because it's stupid, but it comes up every once in a while, is Rolle's theorem. And the problem is that Rolle hated calculus, so he wanted to do everything that he could so that he wouldn't have to use calculus. So Rolle's theorem is like the mean value theorem, but f of A and f of B have to be equal to 0. And f prime of C also has to be equal to 0. So Rolle's theorem only works in certain situations. And honestly, it's one of those things where I tend to forget about it, because if you understand the mean value theorem, then you understand this is just a special case. But it's kind of something that looks like this. So here's going to be A, here's going to be B. This point in the middle here is going to be C, so that my slope here at C is equal to 0. It's just stupid, honestly, but it's there. And sometimes it will be referred to by name, which is why you need to know what it is. But it's a special case of the mean value theorem. I highly doubt you would ever use Rolle's theorem as a solution to something. Like, it wouldn't be part of your explanation. Oh, and by Rolle's theorem, this is true, because you would use the mean value theorem, because that's what I drill into you. Okay. There's one more little piece here, which is something that we haven't thought about in a while, which is the intermediate value theorem. And that basically says that if A and B are any 2 points in an interval on which f is differentiable, then f prime takes on, actually, I don't think it's f prime. Oh no, every value takes on every value between f prime of A and f prime of B and f takes on every value between f of A and f of B. And again, this is just saying if my function is differentiable, that means it's continuous. And that means if it looks something like this, and here's A and here's B, that my function is going to take on every value between A and B. There aren't going to be any holes in there. And sometimes that too will come up. Anybody still need to copy this down? Okay, then what I would like you to do is to go up here and do number 86. And we'll talk about it, and then we'll talk about what the homework is, and that will be the end. Okay, so let's talk about what the information that we're given in the problem tells us. Okay, so if f prime of x is greater than 0, what does that tell you about f? Somebody.
Increasing?
It's increasing. So it's gonna look like this. Actually, not quite like that. Okay, it's gonna look like this. There aren't gonna be any wacky dips back down. So basically that means that when I look at my options over here, the numbers have to keep getting bigger. So are the values in A increasing? Yes or no?
Yes.
Okay, so that's a candidate. How about B? Are those values increasing?
Yes.
Okay, how about C?
No.
No, because I go from 6 to 3. How about D?
No.
No. Okay, so an E?
Yes.
All right, so I've knocked out a couple of options here. And I know you won't have to answer multiple choice questions, but the ideas that we're talking about are still important. All right, so now what I've got to think about is my area from 4 to 7 of f of t dt, just a dummy variable, is equal to 0. So that means that the area under the curve has to be equal to 0. So what does that tell you? What does that tell you about where the x-axis has to be with relation to the curve?
Like it has to cross the x-axis?
Yeah, it's got to cross the x-axis. So here's going to be my x-axis. So that I have some area that's under the curve and some area that's below the curve and some area that's above the curve, preferably in equal amounts. Okay? So again, back to A. Does that have some area under the curve and some area over the curve?
No.
No, right? All of those values, all of those f of x values are below the x-axis. So it can't be that. How about B? Some above, some below? Yeah, so that's a possibility. Let's just check and make sure that the last answer is not a possibility. So let's look at E. Does that have some area below the curve and some area above the curve? No. It's all what, Jacqueline?
On or above.
It's all on or above, so it's not going to be that. Okay? So a lot of this is looking at the information that they give you in the problem and then figuring out how you're going to use it. Okay? So for homework, and I will update the portal, for homework, I would like you to do this number 91. Okay? And I would like you to do this 2014 number 5. Okay? And really all of the problems are different. So I think you'll be okay, even though we haven't done the examples that we're supposed to do in class. Okay? We will do those, we'll still do them on Monday. Okay? All right, questions? Thank you for coming to class today. I really appreciate it.
Thank you.
Okay, and have a great weekend.
Thank you. Bye.
You too.
Bye.